Hello, this is your host, Todd Lewis of the Praise of Fire podcast. Don't forget to like, share, and subscribe and hit the notification bell. Don't forget to follow me on Twitter and Telegram and Facebook. And you can support me on Subscribestar, Locals, and Buy Me a Coffee. Today's episode, Casual Stream 101, Irreducible Complexity, where I'm once again joined by Florian. Glad to have you here, Florian.
Hi.
And we're continuing our discussion on where faith and science meet. We've been doing quite a few videos already on intelligent design. And one of the things we haven't really done yet is look at the arguments in favor of intelligent design. So I also asked Grok for some notes. So we'll go through some of this first. Grok says, Michael Behe's theory of irreducible complexity, introduced in his 1996 book, Darwin's Black Box, suggests that certain biological systems are so intricate that they couldn't have evolved through small successive changes as proposed by Darwinian evolution. Behe argues these systems, such as the bacterial flagellum or blood clotting cascade, require all their parts to work, and removing any part would make them non-functional. This, he claims, implies they were designed intelligently rather than evolving naturally. Now, one argument in favor of this is in Darwin's The Origin of Species, Chapter 6, Difficulties of the Theory, he says this: if it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down. But I can find out no such case. So what part of this theory is based on a list of possible objections that Darwin himself saw as possible objections. And in one sense, this is a broader extension of the design argument in Darwin's own day, advocated by William Paley in the early 19th century. Now, there are three general objections from Darwinians to irreducible complexity. One is acceptation, scaffolding, and co-option. And I asked Grok to define those, and it says, acceptation is when the trait evolves for one purpose but later serves another. Scaffolding refers to temporary structure or functions that support the evolution of complex traits, later modified or lost. An example is the evolution of tetrapod limbs, where aquatic ancestors like Tiktaalik had intermediate forms adapted for water, serving as scaffold for terrestrial limbs. And then co-option, similar to acceptation, involves reusing genetic or molecular components. For instance, the second phalangeal arch in Diotertomes, initially for filter feeding, was co-opted for respiration in fish and hearing in tetrapods. So the first thing I'd say is here to the objections, the idea that you can recycle, so co-option seems to be the idea that you're recycling genetic material, and expectation means you're reusing already existing genetic structures for some other purpose. I don't really see how any of those are actually a refutation of irreducible complexity, because as I've mentioned in previous videos, at one point fish had no lungs. And then according to the standard model, you have then the first fish with lungs, which back when I was a kid was considered Eusthenopteron. Okay, right, but there's no expectation going on here. There's no organ there's no organ which is a lung, which is then co-opted into a lung. That doesn't happen. That's not what's going on with that selection process. And then with co-option, recycling material isn't the same as producing an already established structure. And so I don't really see how these objections hold up as objections to intelligent design, which is saying, I'll summarize it in my own words, if you have a complex system already in place and you remove any component, it doesn't work. So you can think of a steam engine, right? If you remove any piece of the steam engine, it doesn't work. And it's difficult to envision how you could gradually put all of these pieces together and have something useful until you have the steam engine. So you have no steam engine, and you have this gradual process, and then you have the steam engine. Well, in between those two, what you have isn't useful. It doesn't do work. And I don't see how the other examples provided or as objections actually deal with that. But yeah, we'll hand it over to you, Florian. I had you watch some videos ahead of time.
Yeah. So first of all, the comparison between human and biological machines has some pitfalls, namely that human machines, like a steam engine, is constructed from scratch, and then every part of that machine serves a specific purpose. Right? If you take that part away, the machine doesn't work anymore. But biological machines, and that's what you described before with the definition of an expectation, ex adaptation, um, um, that basically you can reuse some elements that were used for a different purpose, and you reuse them now for for another structure. And I'm not even looking at lungs um, to gills or the other way around. But one of these, so if you look at the bacterial flagellum, some elements of that flagellum have been used in other organisms. They are homologous, and they are found in viral injection needles in some viruses. Like they have some injection apparatus with which they put their DNA into a bacterial cell, and these structures are somewhat homologous. So these like small elements of one machine, and Mother Nature has repurposed that for a different machine, right? So that's how that works. So you have a lot of elements of a biological machine of flagellum, in that case, for example, that have been used in different contexts before. So so it's not these things basically still work if you take them away, but they're not put together from scratch by nature, right? Nature just takes an existing system, modifies it. So some components are just along for the ride, so to say. But there's still some components that are of significant importance, right? That we should also not forget that, right? So not every. I would say I would modify Behe's thesis into not every single one of flagellum, not every single element of flagellum is probably necessary. Or if you take that single element of flagellum away, it will probably still work. But there are some central elements that need to be there.
So a couple things here. Um, in fact, let me restate this and tell me if this is what you meant. So you're saying that the reason why, quote, biological machines are, quote, different than human machines is that a human machine is built from scratch and a biological machine isn't.
Right.
Well, right, but according to the standard model, the very first living cell was from scratch because before biology, there's only chemistry.
Right.
So you would still that at that jumping off point, which is actually where all of this gets to, you do have to do it from scratch because there's no other material to work with. It's just chemistry.
That's what I'm saying. So
Yeah.
some elements are very difficult to see how you can take them away. There are many examples how some parts of the machines have been reused in other contexts, and a evolutionary scientist will then say, "Hey, look, there are so many elements that have been repurposed. That's why the entire argument, the entire point of Behe falls apart, and there's just nothing to irreducible complexity." And that's probably also going too far, right? So just because you have seen some elements that can be repurposed doesn't mean that the entire thing cannot, that not some elements in there might have been necessary.
Right. So I'm going to go back to the first objection, exaptation, where it says that a trait evolves for one purpose but later serves another. Irreducible complexity isn't talking about repurposing an already existing system. It's talking about the development of a new one. So I just don't see how that's an objection. That might be because ultimately when you're going from the big change, say from like a fish to an amphibian, there's a lot more than just repurposing that's going on. A lot more than repurposing has to happen. Scaffolding would be the idea of tetrapods. So, now they use the tectonic, but back in my day, it was Eusthenopteron. Again, yeah, sure, fish have appendages too. They have dorsal fins, they have pectoral fins. But again, now you might say, there's the five appendage standard all throughout, vertebrate organisms. But still, there's a lot that isn't there already, and you're not just repurposing the fin to do something else. It's no longer a fin anymore, right? For it to be a repurposing, it has to be basically the same thing. And then furthermore, when you say that you're building off of something, hence scaffolding, this gets back to the point that I've mentioned before, right? If you need to have genes that are going to produce toes and and fingers, that's not in the fish's genetic code for the pectoral fins. So where does that come from, right? The fact that they have some of the material that you might want doesn't, to me, explain how you then modify the code to select for it. So
Right.
Yeah.
Go ahead.
Because there's, for example, in the video I watched, which I don't know if you were able to watch because I sent you the wrong one, or at least I watched the wrong one, the irreducible complexity found in the bacterial cell division from July 3rd of 2024 by the Discovery Institute. Dr. Jonathan McLachty talks about how for humans in the embryonic stage, the 5 digits are created when there's deletion of the cells between them, which they develop through gestation to having fingers. Before that, they're just all like one thing, right? So for a fish, it's still all one thing. You might have the 5 bony appendages in the fin, but the deletion of the cells to create the digits was not done in the embryonic stage. And I fail to see how scaffolding explains how those deletions were made.
Well, we are also talking about different dimensions here. I think what evolutionary biologists talk about are small machines, on the molecular level, right? What appendage, what macro biological structure forms out of that? That's like, if you compare digits and fins, that's several levels above what evolutionary biologists normally look at, right? So we can say there are certain domains of a protein that get accepted or co-adopted or whatever, but that's the level is on a very small micro level, right? And evolutionary biologists will not really have an answer for the larger changes. That's not really something that's not because they're dividing everything into smaller elements. So on the on the molecular level, on the biochemical level, you can identify changes like that, but they're not necessarily looking at large changes. They just then take a conclusion from. They just extrapolate. They extrapolate the small changes on a molecular level into large changes, and they say, "Oh, okay, we see it, and it happens on the micro level, and then this explains how these large appendages could all of a sudden have been formed from one organism to another via evolutionary mechanisms."
So if we look at going back to the definition here, let me see if I find it here. So this goes back to an earlier objection I made about a month ago, right? When it comes to the classification of species, all the way up to phylum is the most fundamental, I think. We've observed changes at the levels of species, but not at family, not at kingdom, and certainly not at phylum. And the argument's going to go, well, it would take too long to observe. I'm like, well, okay, but then my retort would be that's not really science anymore, because science is observation minimally, like when you observe animals in nature. But if we were to look at, say, something like exaptation, where you repurpose something, or co-option, where you reabsorb and use again already existing genetic material, this has to do either with copying. So co-option is copying, right? You're just getting more of the genetic material and then using it in some other way. And then expectation is just using what you already have some other way. But the problem is you can explain some things by copy. So you could have, genetic, you could have a guy with 6 fingers or 6 toes because it was a mutation. It was a mistake. They copied it 1-2 times. But you're not going to expect a mutation to give a man a claw. he might get one more thumb or one more finger or one more toe because, the mutation is a copying error, but you're not going to expect him to get a claw as a result of a mutation. And I would argue that's because we're dealing with copying only explains so much, right? It gives you more of the same, which may or may not be helpful. But it doesn't give you something radically different than what you already have.
Right. Although, if you introduce a gradual change very early in development, you can end up with a very strong change in the adult organism, right? If something compounds what happens very early on, let's imagine um, there's a finger or there's a hand, and for whatever reason, you have a mutation that introduces more keratin very early on, and it also makes some population of cells move faster relative to the remaining cells. Let's say a stream of five cell streams that are early on, let's say in like a little bud where the later on hand is forming. You have five central rows of cells that, for whatever reason, all of a sudden now evolve to be a little bit faster moving outwards than the other cells, right? So maybe 10% faster. Now, in the adult organism, you went from a hand into a claw, something that looks completely different from the original hand, just by a small change on the molecular level early on in development that has simply compounded later on. But I don't know whether any of the whether you can look into that. That would be a hypothesis, but I'm not sure whether you can really look into the entire development of a hand versus a claw, and make that conclusion that it just comes from those small changes in those five initial rows of cells. But that is certainly one mechanism by which large scale changes can arise. Now, that would also mean that you don't really have a different. Yeah, I mean, what's the difference between uh, what is the difference between having a claw versus a hand versus a claw as just some misshaped hand? That's also an interesting difference, right?
Yeah. And then also the distinction between a retractable claw like a cat's or a non-retractable claw like a bear's, right?
Right.
There's also that as well. And so I also asked Grok, and we'll get to this next, I think, what Behe's response was to these three methods that Darwinians proposed. So on acceptation, Behe acknowledges these mechanisms, but contends they do not address the core challenge of irreducible complexity. For example, in the case of the bacterial flagellum, critics suggest it evolved from the type 3 secretion system via co-option. Behe argues that even if parts were co-opted, the simultaneous assembly of all the necessary components remains impossible, as it requires multiple coordinated mutations, unlikely under natural selections. And then on scaffolding, he says, Behe directly critiques the scaffolding analogy, particularly from critics like Baudry, Blanc, and Brakeman, who propose that IC systems could evolve by adding parts first, like building an arch with scaffolding, and then removing them. He argues this lacks biological analogies and specific real-world examples. Behe and Snelk conduct simulations showing that Darwinian evolution is unlikely to produce even simple protein-protein interactions requiring multiple mutations, especially in multicellular diploid species due to population size limitations. Okay, so a couple things here. One of the videos I sent you, I don't know if you saw it, was the actual argument. They sort of flipped the type 3 on its head, that the Discovery Institute was saying that it seems that type 3 is not something that predates the bacterial flagellum, but actually a degradation from it. And that's why they share similar parts. It's not because the type 3 predates the flagellum, but because, and I forget all the reasons they give. I don't know if you saw that video.
No, I don't remember that. So basically, they said that the type 3 flagellum is a degradation from a more complex flagellum.
Well, so the type 3 secretion system, that's what evolution.
secreted system.
The evolutionists claim that predates the flagellum, and that's why they have shared overlapping properties, which they then say co-option allowed to produce the bacterial flagellum. But they were saying that from a whole bunch of perspectives, it looks more like that it was the case that it was a degradation. It was after the bacterial flagellum, and it actually degraded in some way, which is why they still share common parts, but one is more detailed than the other.
Well, the thing is that you can use these arguments. You can use these arguments everywhere and anywhere. Basically, an evolutionist can always say, here that looks a little bit similar. That is co-opted part, and if it's not really clear, then they can always say, well, there's probably another transitional state somewhere that we just haven't been discovering, which could be true, or it could just be could be an imagination, right? So these biological systems are very difficult to define, which kind of reminds me of one argument when we talking about abiogenesis last week, and we said that abiogenesis, there's spurious at best lab evidence for life emerging from an abiotic source, despite the Miller-Urey experiments. But basically, one argument I heard from from evolutionists, basically saying that you don't even need to have a laboratory experiment that works. We can understand how stars develop without being able to create a star in the lab. Well, but in astronomy, you have very clear mathematical formulas in your paradigm with which you can predict a lot. Like Einstein's theoretical physics formulas could predict a lot of things that they later found in reality. Biology is not as straightforward that you can just have a mathematical foundation to predict everything, right? You do need lab work, and therein lies the problem that biological systems are so complex that you can kind of make sense out of them, even though there's some information lacking, right? So it's kind of like you can kind of like imagine whatever you want. It's very difficult to have a clear experiment showing what's happening. And
Yeah.
so then evolutionists can always say, there's okay, if it's not there, it must have been there. It's logic. We see all those changes that we actually see, so we can explain everything with what we see because the rest is probably just like it. But that's a dangerous proposition because you're just overlooking something that may still be there. It's sort of like a little bit like saying, we know sort of how the COVID vaccine works. That's why we don't need to test it in reality and can expedite it and give it out to everyone to get vaccinated without looking for any later development, right?
Yeah.
So I think that's the problem, that we don't have a clear. There's not a clear framework where we can say this evolved or this didn't evolve, right? If you believe in evolution, then you can see it everywhere and you can apply it everywhere. But still, through all these experiments, one thing is true. There are, even if it's not true, even if you can repurpose some parts of the flagellum in other contexts, even if the flagellum has been predated or not by a type 3 injection system in itself, it's still that there are some significant parts of it that can just not. It's just very difficult to imagine they could have come apart by natural parts, right? They could have come apart by some of the parts of the flagellum. There is some kind of basic unit that is very difficult to imagine how that might have been appeared by evolution.
Yeah. So one thing I think that I'm actually surprised that most people haven't brought up in this debate So when we did the review for the 1986 Huxley Memorial Debate, one of the things that Dawkins says, I think he also says this in his debate with Lennox, is that to say that, quote, God did it doesn't explain anything. And I'm like, well, of course it does. If I were to hold up a copy of The God Delusion and then say Richard Dawkins wrote the book, and then some smartass says, well, that doesn't explain anything. You need a naturalistic process to explain how The God Delusion was written. Would we take this person seriously?
No.
Right. So then the question becomes, why is it when it comes to physical goods that we can say are manufactured by humans, we don't entertain this idea. But when it comes to biological systems, which yes operate independently of any human agency, we don't. Even though even Dawkins has said before, it looks designed, but it's not. Well, what does that even? What does that even mean? Because, for example, SETI tries to find communications from extraterrestrials in space by sending radio telescope signals out. The question then becomes, well, why not just assume that was randomly, just like the DNA code is randomly the product of these blind forces? Why not assume whatever message you get for the radio telescope is also the result of these blind forces and not at all the sign of intelligent species?
Yeah, that's a good point. Yeah, I like that. I like that argument because, yeah, if you wish, it's kind of like the faith is like a little bit like the search for extraterrestrial life, no? So with that, like even hardcore atheist biologists will think it's a great idea to look for extraterrestrial life, and they would just assume that there's probably life out there, not that somehow evolved like randomly and then through an intricate process it led to us, but what we hear from outside are just some intermediate processes. No, we assume that there are real that there's real life out there. And as Richard Dawkins even said, from some of these, we could have been spawned. The human race could have been spawned by extraterrestrials, right? So
Yeah.
is that so different from a creator in a way, right? It's probably not.
Well, but you're right. But the point that I'm trying to hone in on here is if we have specified information which forms a language, either words on a page of a book or the 4 letters of the DNA code that determine which genes are selected, how do we if you're going to argue that, okay, the God Illusion was written by Dawkins and saying Dawkins wrote it is an explanation for the information in the book, but then you're going to say, well, but the information in DNA is not the result of a coder. How do you make that call? How do you look at two things which both look like information or code or literature, at least specified complex information, and then say, well, no, one of those was the result of natural processes and one of those was not? Well, how would you even determine that? No one's even told me how you would determine that. And to me, that just seems like a glaring problem. That see the question, the debate hasn't even been framed properly yet, because you have to ask yourself to even have this debate, what is the benchmark for specified complex information that is the result of a human agent, a will, any sort of agency, and that which is not? And
I mean,
nobody, yeah, go ahead.
yeah, if actually if you think about it, let's imagine at one point humanity is extinct, or maybe to be a little bit more friendly, humanity has taken a rocket off the planet, and so there are no humans left on Earth, right? We have populated some planets in some light years away, and so Earth is just empty of human life. And now there is a new alien species that discovers Earth, and this alien species will see that there are books being written, right? And then they look further and they find fragments of civilization. They find some letters around and some words on other papyruses, and they come up with the idea, well, maybe these books haven't been written by someone. Maybe they just emerge through a gradual process of evolution. they would come to similar conclusion if they wanted to believe that books have been written by that books have emerged sort of through an evolutionary process. They would come to the same conclusion, right? They could say nobody else could have written it, right? It's just we don't see any humans. We have no concept of humans. So these books, they just arrived on the scene through a gradual process of evolution. They would basically say the same, right? But
Mhm.
it's not. That doesn't mean. Then of course it doesn't mean that's really what happened. But they would come to the conclusion, and it doesn't really mean that the opportunity or that the possibility that there were humans that actually wrote it doesn't exist. They just
Yes.
assume that what they say is just a gradual evolution because that somehow makes sense to them, but they can't. That really doesn't refute that there are actually creators or authors of this book existing. Right? It's a good
Yeah.
point. Um,
But also to add to your point, if you were to hear a signal in space with SETI, why
right.
not just assume, like the specified complexity of information in the DNA, that that's just some accident of the background radiation? So, if you get the message ET's here, well, the people operating the radio telescope are going to be like, we made first contact. But I'm going to be like, no, that's just the background radiation randomly giving you specified complexity. I mean, why not, right? How do you tell the difference?
Yeah, because you tell the difference. The only way you tell the difference is that you say, okay, they have they have a purpose, right? They have a purpose. They are talking to us. These messages are for us or for anyone like us who might listen into them, right? They've been sent out for a purpose. That you would surmise that, right? Because it's far too significant and it fits to us, right? It fits to us. It's not some random evolutionary. And I don't mean even like that's just random rolling the dice, but it's not an evolutionary process. It has been sent with a purpose, and maybe that's the difference, right? There's a purpose behind it, and that makes a difference between something
Ah,
being due to creation or due to random evolutionary change.
right. Okay, that's an important point to touch on here, because the problem that I have with modern scientific assumptions is that there isn't a telos or purpose in nature. Because what you're talking about is telos. If somebody's giving you a message, there's a purpose for that message, right?
Right.
So let's take this out of the hands of the creationist evolution debate and go back to Aristotle. Aristotle said that natural processes had goals, and his famous example was the acorn, which had the potential to become a tree. And when it became an oak tree, it actualized that potential. And of course, he argues that telos is baked into the concept of the acorn. Okay, now I would argue with Aristotle, right, that all of these biological functions do have purposes. And if purpose is part of the, because it has a process that it maturates into, unless through death or destruction, that process is disrupted. And that itself is a goal, that itself is a purpose. And if we're going to use the SETI example of, ET is here, then I would argue that biological systems do meet that criteria. But the problem is, this actually goes back to even before Darwinian theory. Western philosophy moved away from formal and final causes in nature, which, as far as I can tell, wasn't actually ever justified. It was just a fiat that occurred, and the academy went along with it.
Yeah, certainly. There's a lot of historical and political realities that intersected with it here, right? So I would even say there was a concerted effort in the West to do away with religion. Most famously in the French Revolution, they just completely decapitated the Catholic Church, and to this day they have a separation of state and church in France, right? And then the church was pushed back as sort of like getting into elite theory here, but the church was pushed away as an authority, as a ruling class. So what we basically see in the evolution and creation debate is some echoes of that wish of doing away with the church as a ruling class in a way, right? So many of these things, the deeper you go, the more you realize that there is at least the creationists don't there's not an concept that has aged out. It's there's many aspects of it that you could find that are completely perfectly explainable and could be perfectly part of our scientific canon nowadays, but they are somehow not, because there's an effort to get the religion away from the public sphere, which is an effort of a secular ruling class to get rid of a religious ruling class, which has been going on, I would say, until the middle of the 1819th or middle of the 19th century in earnest, right? So we're getting into that too. It's interesting to ask ourselves why do we actually try to overcome religion, right? Even the Enlightenment at first didn't try to abolish religion, but probably that's something that has been the logical conclusions of political evolution.
Well, yeah, and on Grok, one of the things it pointed out was that irreducible complexity is rejected on the. this is rich, especially in light of when we expelled. It says here, legal and cultural context. The theory gained significant attention in 2005 Kitzmiller versus Dove area school district trial, where Behe's claims were scrutinized. The court ruled that intelligent design, including irreducible complexity, is not science but essentially religious, noting that Behe's arguments have been refuted by peer review research and were not accepted by the scientific community. And then there was another one, peer review. Came up again. Quote unquote refuted. Here, conclusion. This is also from Grok. It says, well, he argues it highlights the limits of Darwinian evolution. The scientific community leans toward evolutionary explanation supported by peer-reviewed research. Right, but as we saw in Expelled, Florian, you won't get peer-reviewed if you try to push intelligent design. So that's putting the cart before the horse, right?
Yeah. Yeah, indeed. So I think I went a little bit out of the. I think I left the trajectory of the core of this discussion. What was the last point we mentioned before I went into the tangent?
Oh no, that was okay. No, so what led to this? I think it's related. So I was arguing that the debate itself isn't properly framed. Because if
Right.
we're going to argue that specified complexity in the form of Richard Dawkins' The God Delusion is evidence of design and evidence of Richard Dawkins writing the book, why is that specified complexity not evidence of design in DNA? And then furthermore, if you're going to have a radio telescope pointing to space and you get a message back that says ET is here, why not just assume that's background radiation of the universe giving you a random specified complex message like in the DNA code? Nobody would assume that. They would assume that that is an intelligent life form. Well, then that begs the question, when is specified complexity a sign of intelligence and when is it not? And as far as I can tell, nobody's even begun to define the parameters for that. And to me, that seems to be one of the biggest problems with this entire debate.
Yeah, right. Because without these parameters, you can just put it into every which direction you want to. So, but it's a deep question. It's not as easy to answer. I think that I think I lost my train of thought a little bit here, but
that's okay. It happens.
I don't know. Actually, I don't know because the the big flaw I see in evolutionists, in people that say there's just no God and there's no creation, and we can just explain it by purely scientific, like some purely scientific principles and purely abiotic evolution and giving rise to life. It's all it's at a certain point it's all conjecture. It's basically, you don't there are no clear experiments that would that would that would show continuously that there's no clear paradigm. Like you have in astrophysics, you have a paradigm, how the universe evolved, right? You have some calculations that you can do. You don't have such calculations in biology, and that's a bit of a problem. So what biologists will say is, look, we have so many different cases where we can show that structures in the body that look complex, they come from different backgrounds, they have been repurposed, and so on and so forth. And so we just assume that everything has just evolved. But that's just an assumption, because you never know how much you don't know, right? You look at some observations that you make, but you don't know whether those are all the observations that are out there. Of course, they're not, right? So you don't know whether you are on a path that's completely in the wrong direction, or whether your observations really are at the center of the problem.
Yeah. Well, the other thing too is because again, it's the design implications of irreducible complexity that is the bone that sticks in the craw of a lot of these scientists. When Dawkins says, and he said this many times, but we heard him say it in the Lennox debate, it does no good to appeal to God as the designer, because you have to ask the question, who designed God? Now, first of all, I won't get into the metaphysics of that because that's a malformed statement. But more to the point, of course it explains it. Because if I want to say, what is the explanation for the publishing of the God delusion? And I point to Richard Dawkins. Is Richard Dawkins going to say, whoa, no, Todd, I mean, you have to explain where I came from. That's not an explanation. Of course he'd accept it. That's just bad faith. I mean, you still have to have, because even if Richard Dawkins had to have parents, and they had to have parents, the thing is, you still have to explain how the God delusion was written. And it was produced by Richard Dawkins. And so saying that by appealing to an author to the book, that's completely valid. We do this all the time.
Yeah, I mean, why would they even be something like, why are we, and we come to the question again, why is evolution producing humans that are able to reflect back on their origin, right? So why would that happen? What advantage is there for humans to just be there and be capable of thought when there's no purpose really behind it? If it's just trying to implement the survival of the fittest, then we don't need to be a self-reflective species. Now, biologists would say it's important that we are self-reflective, because that gives us an evolutionary advantage, because we can make plans how to attack our prey, how to defend ourselves against intruders, and all things like that. But it is remarkable that we also have humans that are basically have an urge to think about philosophy, which does not really give you any direct survival advantage. So there must be more than just like a direct interaction with the environment and giving you a direct advantage from that.
Now, somebody in the comments section weighed in on the SETI claim. D. Reverend at 637 says the distinction with SETI would be that the coherence of the message would not influence the probability of a natural message being sent, and so you would not expect a coherent message. Well, I mean, the same could be said about biological information in cells. I mean, we know from Shannon's information theory that information is either, if no extra information is added, it's either preserved or degraded. Now, if you take an evolutionary model and there's no designer and there's nobody inputting new information, what's preventing all of this from degrading? I mean, because it should. Under natural circumstances, the information would degrade, which would lead to cell collapse and death. But biogenesis, the creation of living organisms from other living organisms seems to be adding information, at least preserving. It's preserving the information that was there to a much greater degree than you might expect under any other natural process.
Yeah, because a biologist would say, whatever doesn't directly hinder our ability to survive in our environment doesn't need to be, is not under no evolutionary pressure to be eliminated, right? So it's just there as a mutation, but it doesn't really doesn't really matter much. So that need doesn't and degradation happens over generational timelines, and our generational timeline is very long, right? So 20 years for one generation. It takes a while until it degrades, and then you have other effects that are pushing evolution in a certain direction. So if it's not really hindering, then hindering us in surviving, then it will not really degrade. But it may actually degrade over time, and Shannon, that would be according to Shannon's hypothesis, but it doesn't need to do that immediately. Now, but still, that is not something that's some hand waving argument, right? It's not something that is it's just some explanation that you have, but it's not really tested. That's just some explanation we say, oh yeah, that could explain it, but it doesn't mean that's true.
Well, let me give you an example, right, Florian? So one of the things in science that you're supposed to avoid are quote ad hoc explanations. So if a theory has a challenge, you don't want to have a plug for that hole invented merely to plug the hole. You want to have some independent reason for believing that that principle already exists, and then you can then use that in order to shore up the theory, right? But the problem is, what I see with a lot of this is that the evolutionist is assuming something that he hasn't proven. And so from that assumption he hasn't proven, he keeps on, he's like, well, of course, this must be the case, this must be the case, and this must be the case, because I have reason to believe that this broader theory is true, and whatever problems we have in it can be solved this way. But what I would argue, though, is that this is circular reasoning, right? Because one of the errors of thought is the idea of assuming what you're trying to prove. So we see this all the time when they criticize Christians or creationists in apologetic debates, saying, well, you can't assume God because God's what you're trying to prove. And I'm
Right.
like, okay, but you know what? You can't assume evolution if that's the thing you're trying to prove. And what ends up happening discreetly is that they end up constantly assuming what they want and then masquerading that as an argument, which, is again circular reasoning. You can't do that, right? You have to actually look at the challenges. And to be fair, Darwin has a whole chapter devoted to these challenges. That seems to show a level of fair-mindedness we don't see today.
Well, there's also, yeah, I mean, you can always you can always steer a discussion into the way you want to have it, and by just assuming that your null hypothesis, basically your default state, is what you assume should be there, right? So if you assume there's evolution is the default state, then everyone needs to make an argument to show that evolution does not happen. So any information that's not strong enough, you can always fall back to saying it's evolution. But yeah, that's what you said. Basically, you assume that what you want to actually show in your arguments, and then any argument you will always be on the winning side because your default state is already chosen, and that frames the entire argument, right? And that's why sometimes you don't get any on any ground with evolutionists, because they just say evolution, that's the default state, and we don't really need to think about all this. It's clear, and you need to come up with good arguments for the existence of a god or for the existence of creation, because we know based on our handful observations that evolution is real, um, and 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 that's a problem of discussion. But
I might call that Darwin of the gaps, Florian.
Darwin of the gaps. Yeah, but also
Right?
it's good that you. But also, I think there's also we we are focusing too much on Darwinian evolution, which basically is this is just one aspect of evolution, how it can happen, right? Evolution doesn't need to always be. Change doesn't even need to occur through random mutations. Change can also occur through the exchange of whole strands of DNA, right? It's more complex. It's more complex than that. It can you can have your machine, um, your irreducible complex machine. You can have you basically can evolve it in a different function by taking the entire part of the machine and putting them into a different region of the DNA. For example, I think that was one of the things they found in the long-term experiment where they had bacteria in a lab condition, and they basically changed the nutrient medium every day, and then they observed since 1988 whether there are any changes, and they found that one of these bacterial strains, they were all of a sudden be able to use citrate as a nutrient source, not just glucose, so normal sugar, but also citrate, and uh, and bacteria couldn't normally do that under conditions where there's oxygen available. They could only switch to using citrate as a nutrient under anaerobic conditions, so when there was no oxygen available. And one of these strains actually, what they found is that the entire gene that was used that was used for using citrate as a nutrient source under anaerobic conditions was moved right next to a promoter, right next to a regulatory sequence that would allow genes expressed under aerobic conditions when oxygen is present. So now all of a sudden those bacteria could use citrate as a source under oxygen present. So that's a very, very drastic change, but it's still the entire enzyme that could use up citrate instead of glucose. That entire enzyme, that DNA for the entire enzyme, was moved on the entire genome, right? So once again, this thing wasn't evolved de novo. This thing was taken as a brick and put someplace else, and now the bacteria had different properties.
Okay,
So
so
for,
that
to
sounds
me
like.
that basically to me that basically shows that there is that that basically there's some irreducibility and complexity there,
Mhm.
right?
Well, that sounds like co-option, where you just take some genetic material from one area and then move it to another area. But here's the thing, right? One, the genetic material was already there to be moved. But
Yeah,
then second of all, with speciation, like for example, the finch beaks that Darwin observed, some getting bigger, smaller, changing. The first of all, the intelligent design advocates and creationist advocates are going to argue that there's a level of plasticity within biological organisms where yes, they will change slightly under different circumstances. But one of the challenges raised though, especially with like say something like finch beaks, is to what extent these changes are permanent, right? Because not only does the Darwinian mechanism assume that gradual changes over time will lead to greater changes, the other question is, though, will those changes hold? Because, for example, if the environmental conditions change and the beaks get smaller again, they're not going to be preserved because the condition that led to them to change in the first place has now been altered.
right.
And so that's another question. I don't know anybody who's talked about the probability of even these small changes being preserved over a long enough time frame for the big change to happen. Because it's one thing to say that a lot of little changes can lead to a big change. Okay, that's a separate argument. But what's assumed is that those little changes stay, not that they stop. But do we know that?
No, the point would be that they're just tolerated there, and you get that from like looking at the DNA and seeing that there's not much change happening. There's a base pair change here. There's a base pair change there over time, and it's kind of there, but there's no immediate pressure to remove it. right? So it can be there, and can now, when if you want to have a bigger mutation, the entire DNA is by coincidence sensitized for that new mutation, and that new mutation can now appear in that sensitized version of DNA. And over time, these can vanish indeed, and they will, these mutations, if they don't give an immediate advantage. Also, this long-term experiment that they have done with bacteria in a lab, bacteria have a very, very rapid generation time, right? They have, I don't know, 20 minutes, an hour, and they're very, very simple. They just divide, right? That's how they multiply. That's very different from even an insect or mammals, or like, not even to say humans. So it's one thing to look at evolutionary change in bacteria, but to extrapolate from that into mammals or mammalian organisms is a bit of a stretch. But all the arguments that evolutionists have is basically from those biological model systems, and that's very clear that you use bacteria because you can handle them in lab. If you want to test a hypothesis in evolution, you use a model organism that develops that quickly, because then you have a chance of observing the outcome of your experiment within a 3-year period, and can write your thesis about it or your paper about it, right? The more complex the organism, the more difficult it is to make research. So you always need to keep in mind what evolutionary biology is referring to is basically model organisms. That's where they have all their knowledge from. These are models, from bacteria to mice. These are all organisms that are much less complex than humans. So it's not at all clear that you can so easily make the case it happens in bacteria, so it must be true for humans as well, right? Aspects of it will, but how much? But if you look at more granular things, or more subtle things, um, uh, then more nuanced things, then these nuances are the things that are probably changing between bacteria and human, right? What is a nuanced change in bacteria is maybe not even possible in humans. That's also something we need to keep in mind.
Well, and so when it comes to, say, the mechanism of speciation through the peppered moths or the finch beaks or bacteria or whatever, it's not that observable data is being objected to by the intelligent design advocate. It's how is the data to be explained? That's number one. And then number two is, what could we reasonably extrapolate from that data? Because what a lot of that looks like to me is the fallacy of the hasty generalization. So in any sort of scientific process, just because it works at one stage of the process doesn't necessarily mean it's going to work in the other stage. And that has to be proven, not assumed. And I think too often it's assumed.
For example, this LTE, this experiment is a good example where you can also learn about that. So basically, I just talked about how they found that the bacteria now, some of the bacteria now could use citrate as a nutrient source instead of glucose. And so then people say, okay, this is an example of macroevolution, and this is an example this is a refutation of the principle of irreducible complexity. But if you think about it, okay, a bacterium that can now use citrate as a source versus glucose as a source, is it really big of a change? And then biologists will say it may not be big, but it is a macro level change compared to the micro level change that we observe. Yeah, for bacteria, but this is not akin to a chimpanzee, or like to some monkey precursor evolving into human or chimpanzee or whatever, right? I'm not even sure whether you can compare this to an evolution of a Neanderthal man to a modern Homo sapiens, right? So So this is a little bit dishonest. Yeah, great. Congratulations. It's a macroevolutionary change that you observe there in your bacteria world. But humans are a little bit more complex than bacteria. And so you're exactly right. Hasty generalization. And you know, um, I think some biologists really need to really need to take a step back from their optimistic and self-assured behavior. Let's say it like that, because it's not just because you see it on a small scale doesn't mean it's not now valid for everything, right?
No,
A
so
little bit of humility would go a long way.
with what you described in that experiment and the distinction between microevolution and macroevolution, that what you described sounds like speciation. So that I don't think anybody would find that to be objectionable or difficult to accept. For me, when I hear macroevolution, I think of a jump from like a domain to a kingdom, or a kingdom to a phylum, or a class to an order. That experiment doesn't go anywhere near to showing that those jumps are possible.
Right. Right, but biologists will say, "Well, that's not really important. You intelligent design people, you were talking about such changes not even possible. But in our biological paradigm, that is possible." And yeah, and then the argument starts to become theoretical and philosophical. And the problem is that the same people that basically rail against ID people or creationists will then go on CNN and say, "Haha, we found a way to refute these people," and everyone believes them because now you're basically leaving the realm of your defined environment, and you just extrapolate it for everything because then CNN has you on their show, and that's how it works, and that's one
Mhm.
other big problem, right? You have, and this is again with all what we talked about, the new atheism, all the branding that went into it. There's tons of small, how say that small stretches in the extrapolation are just a hasty generalization, have just been has just been promoted to knighthood just because the branding was just because it fit the branding, but it's not really. If you look more closely, it's actually a scam. If you want to go so far,
Yeah,
right?
yeah. So I think we're about done with this conversation. I'll just reiterate the intelligent design argument, or not intelligent design, the irreducible complexity argument. The idea is that you have complex biological systems. Now, that may not be to say that every biological system is this complex, but some are, right? And those are the ones that Behe's trying to explain, and that they need all the parts working together. And so, for example, you have parts, no steam engine, then you have a steam engine, then you have this intervening middle space where if it were done gradually and not all at once, you wouldn't have a steam engine, you wouldn't have anything to do work. And so what Behe says is, okay, well, there are organs or biological structures like this in nature. Therefore, they are sufficiently analogous that we should take this into play. Now, if the objection is that, we have these other mechanisms we've already discussed, acceptation, scaffolding, co-option, but then I would say, well, how do you know that the radio returns from your SETI space telescope aren't just background radiation that's specifically complex, like the information in the genetic code rather than ET saying hello? I mean, they don't have any means by which you could even address that question. And so that's what I'll end with. But what would you end with, Florian?
I would end with that. I think that it's still more misunderstanding, and I think what biologists who are arguing against creationism, they I don't know how else you call it. They basically weaponize misunderstandings and mischaracterizations. They basically use their small systems, and then they project this is just that this is just they showed it in a small level, so now it's true on the macro level as well, right? So they basically say, so the thinking is this: um, bacteria use small machines, and since we have seen those aspects of small machines repurposed, rescaffolded, In other bacterial cells, now that shows that everything on the macro level world is the same, right? And that's just a hasty generalization, and I think that's one way that that they just make statements that are not necessarily holding up if you look closer, but nobody looks closer because they have some gotcha against creationists. So although as a statement, I would say you shouldn't trust what you hear. You should really look deeper into the details behind it, and then derive your opinion from that.
Well, all right. That wraps it up for tonight. Thanks again, Florian. It's always a pleasure having you on. This is Todd Lewis of the Present Podcast signing off.